And to round out our work on function composition, our last example is going to be doing some function algebra graphically. So we've got g of x as the linear function over here, and f of x is this parabola. So the first one is f plus g of 2, which just means f of 2 plus g of 2. F of 2 means going to 2, finding the function value associated with it, which is 2. And then g of 2 means going to x equals 2, but now we're looking at the line because g of x is the line, and that's 3. And then 2 plus 3 is just 5. I'm going to go ahead and label these with their names so I don't get confused later. Okay, f divided by g of 3 just means find f of 3 divided by g of 3. So we're just looking on the function value. So f at 3 is negative 3 divided by g of 3 is 3. G of 3 is 5. So negative 3/5. Now function composition, f of g of 2, means first I need to find g of 2. So g of 2 is 3. Now we're doing f of 3. So after I found that my g value was 3, so g of 2 is 3, now I'm going to turn around and go back to the x-axis on 3 and find the function value for f, which is negative 3. So I kind of went from an input to an output, then I turned that output around to an input for f and found its output. And our last one is g of f of 1. So first I find f of 1. F of 1 is 5. So now we're finding g of 5. Now g of 5, this is purposefully a little bit tricky because I can't tell where g of 5 is. But what I can do is use the fact that this is a linear function with a slope of 2. So if I'm going to 4, so if we just think about this x versus g of x, if I'm at 4, I know that my y value or my g of 4 value should be 7 because right here I was at a function value of 5. I'm going to go up to right 1, and then if I go again to 5, now I should be at 9. So g of 5 is 9. We could also notice that g of x looks to be the function 2x subtract 1, so g of 5 would just be 2 times 5, or 10 subtract 1, which is 9. So that is the end of our section on function composition.